Hey everybody, we're live in stereo. Now I'm going to do the 2024 set for moles and stoichiometry, and this is a snippet that has been attached at the start because you'll realize that later on you'll see such MCQs. Back in our day, such MCQs were very common. Nowadays, it's not that common. A means 1, 2, 3, B means 1 and 2, C means 2 and 3 option, D means 1 option. So, back in the day, 10 MCQs used to be given to you at the end, and they used to be so similar, and you'd have to select whether 1, 2, 3 are correct, whether 1, 2 are correct, 2, 3 are correct, or 1 is only correct. But this snippet is going to be given at the start of every MCQs because we will be covering all the previous year's past papers as well. So you guys can see this stuff later on. But for now, it's none of our concern. Glauber's salt consists of crystals of hydrated sodium sulfate, which can be used for the manufacturing of detergents. And hydrated salt questions, we've already been doing them from O-levels and IGCSE. If you don't remember them, you can watch the videos on the portal. When a sample of Glauber's salt is heated, 1.91 grams of water was removed, leaving behind 1.51 grams of sodium sulfate, right? So this is the hydrated salt, and when you heat it up, how many grams of water is removed? 1.91 grams of water is removed. And how much Na2SO4 is left? It's about 1.51 grams of Na2SO4 is left. Now you're saying, what's the value of X? We know how to solve this. What do? We calculate the moles here. We calculate the moles of H2O here, right? So how do you go from mass to moles? Mass equal mole times molar mass. For sodium sulfate, mass is what? Mass is 1.51 grams for sodium sulfate. Moles of sodium sulfate, molar mass of sodium sulfate, 23 times 2 plus sulfur is 32.1 plus oxygen is 16, times it by 4. What do we get, sir? N is equal to 1.51 divided by, what's the mass of sodium sulfate? Let me quickly calculate it. 23 times 2 plus 32.1 plus 16 times 4. That gives me 142.1. And so what do I have? 1.51 divided by 142.1. I get 0.0106 moles. Done. These are the moles of Na2SO4. How about the moles of water? Well, you have mass equal mole times molar mass. Mass of water is this much. Moles of water I need to calculate. Molar mass of water is what? It's 18. 2 plus 16, right? Hydrogen is 1, times it by 2. So 2 plus 16, 1.91 divided by 18 equals the moles of water. Moles of water, what do you get? 1.91 divided by 18 is 0.1061. So you have moles of water and you have moles of sodium sulfate. Now why did we need it? We needed it because we said, hey, if you had 1 mole of sodium sulfate, you would have X moles of water in it. So if 1 mole of sodium sulfate has X moles of water in it, I already know that these many moles of sodium sulfate has these many moles of water in it. So 0.0106 moles of sodium sulfate has 0.1061 moles of water. So what's X or N, whatever? X equals 0.1061 divided by 0.0106. Cross multiply. 0.1061 divided by 0.0106. I get 10 moles. And this is just a basic question of hydrated salt. So you guys can watch the video of hydrated salt if you've forgotten it. Yeah, so 10 moles. Which contains the greatest number of named particles? So 6 dm cube of argon atoms. Now please understand, when you see such questions, please do not waste your time. Do not waste your time by calculating the particles. No. Unless, in this case he says carbon dioxide atoms, right? Then you can go for it, but even then I'd suggest not calculating the number of particles, because realize, where will you have the greatest number of particles? Well, you'll have the greatest number of particles where you have the greatest number of moles, because more the moles, the more the particles. So I'll just calculate the moles, and the one that has the most moles will have the greatest number of particles. That's it. That's pretty basic. These are the tricks that you need to use in MCQs to save time. So I have 6 dm cube of argon. I know V is equal to N times 24. Volume is what? 6 moles I need to find, times it by 24. N is equal to 6 divided by 24. What do I get? 6 over 24, that's 0.25 moles. So I have 0.25 moles. And in order to calculate particles, I can literally just multiply it with the Avogadro's constant, which is 6.022 into 10 to the power 23. But I don't want to do that. I don't want to waste my time, right? 6 grams of carbon dioxide. So mass equal mole times molar mass. What's the mass of carbon dioxide? That's 6 grams given. Moles, I need to find molar mass of carbon dioxide is 44. If you did not know that, let me just make you calculate it. Carbon is 12, oxygen is 16, times it by 2, right? So 6 divided by 44. This will give me the moles of carbon dioxide molecules. So moles equals 6 divided by 44. 0.1363. And see, now you also realize a trend. You're given grams. You're given masses. So you don't have to write down the formula over and over again. You just know mass divided by the molar mass gives you moles, right? You've literally written down the formula right here. So instead of writing this formula over and over again, I can literally do what? 6 divided by the molar mass of magnesium is 24. 6 divided by the molar mass of water is 18, right? So you could do it directly. You can do these things directly. It's 24.3 effectively in O level, in AS level, if I remember correctly. Because if I look at my periodic table, let's see if my memory serves me right. Absolutely. See, in your periodic table, these are a little different. So it's 24.3, not 24 like in O levels. So 6 divided by 24.3. You get 0.2469 moles. And 6 divided by 18 was 0.33. So which of these is the highest number? Is 0.25 the greatest number, 0.13 is the greatest number, 0.24 or 0.33? It's 0.33 obviously. So D is the correct option. And see, it's so important to look what's written. Molecules. So yes, I would multiply it with the Avogadro's constant, it's going to give me molecules. Atoms. Yes, I'll multiply it with Avogadro's constant, gives me atoms of magnesium, gives me molecules of H2O. This is carbon dioxide molecules. This would give me carbon dioxide's molecules if I multiplied with the Avogadro's constant. Please always remember to look at this, because if this was atoms, let's suppose this was carbon dioxide atoms, then I would calculate the moles of atoms. So whatever I would get, I would multiply it with what? With 3 to get the moles of atoms, right? So this is very important to be careful here. A very important point to be careful for here. 7.5 grams of nitrogen monoxide reacts with 7 grams of carbon dioxide. It's a limiting and excess question, or right off the bat, because you're given two data. He's saying this much nitrogen monoxide reacts with this much carbon monoxide, and it on the surface of a catalytic converter in the exhaust system in the gas, what's the total volume of product gases produced? So you should be able to write the equation on your own, right? So nitrogen's oxide and carbon monoxide, they react together to give you what? Nitrogen and carbon dioxide. The catalyst that you use is usually platinum, platinum or rhodium. And how do you balance it? It's just 1/2. You had one oxygen, one oxide, 2 on the left, 2 on the right, one carbon, one carbon, one carbon on the left, one carbon on the right, and you had one nitrogen here, so I just halved this stuff, right? Now, he's given me grams of nitrogen monoxide and grams of carbon monoxide. Let's both convert this into moles to figure out which one is limiting and which one is excess, right? And please understand, it's 1:1, right? So the moles of NO needed should be the same as the moles of carbon monoxide that should react with the moles of NO should be the same. So let's see if they are the same. That's the first thing we need to take care of. So mass equal mole times molar mass. Right, mass of nitrogen monoxide is 7.5. Moles of nitrogen monoxide I have to find. Molar mass of nitrogen monoxide, nitrogen is 12, carbon is 12. Sorry, nitrogen 14, carbon is 12. N is equal to 7.5 divided by what? 26. What do we get here? And similarly, carbon monoxide, for carbon monoxide, how do we calculate it for carbon monoxide? Again, mass equal mole times molar mass. Mass is given, equals mole times molar mass is what? 12 plus 16, which is 28, right? So 7 divided by 28. How many moles do we get? 7.5 divided by 26, which is 7.526 is correct, right? 12 plus 14, 0.288, right? And 7 divided by 28, that gives me 0.25 moles. Now, between these two, which one is the limiting reactant and which one is the excess reactant? Please understand that in O levels and IGCSE, when we used to calculate the moles of both, then we used to compare one, right? And in A levels, we see it with our naked eyes that for 1 mole was required. So if you had 0.025 moles of carbon monoxide, 0.25 moles of carbon monoxide, 0.25 should have been required, but you have more. So this one is in excess, right? This is excess. You don't even have to prove it. It's in excess. Why? Because see, 1 would react with 1. So 0.25 would react with 0.25, but you are only left, you only have 0.288. You have more. How much excess, by how much is nitrogen monoxide in excess? By how much is nitrogen monoxide in excess? You can even calculate that. 0.288 is available minus 0.25. You can even calculate that. What does that give me? 0.288 minus 0.25. I'm just doing this extra calculation which is not required, but this is these are the moles of nitrogen oxide which are in excess. I don't even care about this. This is in excess. I don't care about it, just to prove it to you that it's in excess, right? Now, we know we do our calculation with the limiting reactant, and I always give the same example. For example, if you were to make a house with bricks and you needed 10 bricks and 1 bag of cement to make a house, then 10 bricks and 1 bag would give you 1 house, 20 bricks and 2 bags of cement would give you 2 houses, but 30 bricks and still 1 and 2, and the 30 bricks and 2 bags of cement would still give you 2 houses, because the cement becomes limiting, right? So limiting reactant is carbon monoxide, and we're going to do our calculation with carbon monoxide. And understand that I have the moles of carbon dioxide, and these are both gases. These are both gases, right? And I need to find out the total gases produced. I need to figure out how much gas this is produced, how much gas this is produced. So I'm going to do an easy way. I'm going to do an easy calculation. What I'm going to do is I'm going to convert this into volume, and I'll tell you why I'm doing this. V is equal to N times, and it's given in dm cube. So V is equal to N times 24. V is equal to moles is how much? 0.25 times by 24. What do we get, sir? 0.25 times it by 24. It's 6 dm cube. Do you know why I converted into volume? Because you'll realize that, sir, you have taught us this, that why not do stoichiometry? I have the moles of nitrogen monoxide. I will then find out the moles of nitrogen, and then I am going to find out the moles of carbon dioxide, and then I'm going to convert both of these moles into volumes. You could do that. You could do that, absolutely. You have 0.25 moles of nitrogen monoxide. So 0.25 moles of nitrogen monoxide you have to go into nitrogen, so it's half, right? I'll divide it by 2. These are going to give me the moles of nitrogen, and then you could convert it into V is equal to N times 24. You could convert it into volume. Similarly, the moles of carbon monoxide that you have here, 0.25 divided by how much? Nothing, because 1 mole of carbon monoxide gives you 1 mole of carbon dioxide. So these will also be the moles of carbon dioxide, and then you could convert it into volume, right? I don't want to do that. What I did was, instead of converting the moles of carbon monoxide into the moles of nitrogen and the moles of carbon dioxide and then converting into volume, what I did was I just converted this into volume. And the reason for that is pretty simple. I know that these are all gases, and if I have carbon monoxide written here and N2, half N2 written on the right, and I have carbon dioxide written, I know that the volumes that I have, the molar coefficients that I have, and the volumes that I have, they are literally the same. So 1 mole gives you half a mole of nitrogen, and 1 mole of carbon dioxide is as good as saying 1 decimeter cube gives you half a decimeter cube and 1 decimeter cube of carbon dioxide, right? So if I have 6 decimeter cube of carbon monoxide, how much nitrogen would I get? So half of that, which is 3 dm cube. And how much carbon dioxide would I get? The same, 6 dm cube. So I'm going to add them. This is the total volume right here. So what's the total volume? 9 dm cube. Done? 9 dm cube. And it's also very important to, why did I circle 12? Sorry, my bad. 9 dm cube. C, right? And it's also very, very important to understand one more idea. The idea is, here the examiner has asked you what is the total volume of the product gases. Do you know why this was so crucial? Why is this so crucial to specify? Why is this so crucial to specify? Why? He only wants products gases. He wants nitrogen and carbon dioxide. You understand that you also have nitrogen monoxide, which is what? Which was in excess. So at the end of this reaction, you also have these many moles of nitrogen monoxide which are left. And when you multiply it with 24, you will also get the volume of nitrogen monoxide that's there. So if the examiner ever asked you, instead of asking you to calculate the total volume of the product gases, if he asked you to calculate the total volume that is being produced, the utmost total volume that is left after the total volume that you have after the reaction is over. So you have 9 dm cube, and you also have this much volume. So you'll have to add these two then. So C is the correct option for now. This question, 0.216 grams of aluminum carbide Okay, reacts with an excess of water to produce methane gas. This is the only carbon containing product formed in the reaction. This methane gas burns completely in oxygen to form H2O, carbon dioxide, the volume of carbon, blah blah blah. What is the formula? Oh, this is a good question. I want to explain and dissect this question in its utmost entirety. Right now, he's saying that you have 0.216 grams of aluminum carbide, 0.216 grams of aluminum carbide, and he wants the formula of aluminum carbide. You don't know how many aluminums you have, you don't know how many carbons you have. That's a very important question. Okay, I don't know how many aluminums I have, I don't know how many carbons I have. And he's saying it reacts with excess water to produce methane gas, and that's the only carbon containing product that is formed. So AlXCy, I don't know, but I don't know how many aluminums there are, how many carbons there are, but he's saying when it reacts with water, it gives you methane, the only carbon containing product that is formed. And what else is it going to give me? Well, you don't need to know that, but if carbons and hydrogens form methane, then aluminum and the OH would form aluminum hydroxide. You don't need to know this. This is the equation for it. You don't need to know this aspect for it. I'm just concerned about this methane. Why? Because now the examiner is saying that this methane would do what? This methane gas burns with oxygen to give you carbon dioxide and water, right? So this methane burns, always follow the steps. This methane burns in oxygen to give carbon dioxide and H2O. Done? And can I balance this? Absolutely I can. So you have 4 hydrogens on the left. I'm going to add a 2 here to make this 4. How many oxygens do you have? 2 plus 2. 4 oxygens on the right, and I only have 2 on the left. So what should I multiply 2 with to get 4? X is equal to 4 over 2. That's 2, right? So 2 oxygens. Done. Now he's saying that the volume of carbon dioxide produced at room temperature and pressure is 108 centimeter cube. 108. So carbon dioxide which is being produced is how many centimeter cube? 108 centimeter cube. And he is saying work out the formula of aluminum carbide. Now what's my known data? I basically have to do reverse working. I have to go from carbon dioxide to methane, then connect this methane to this methane right here, and this methane to carbon right here. And so it's a huge process. I'm going to dissect this process for you, and you'll understand it at the end of this dissection. But it's like reverse working, going from carbon dioxide to methane and then connecting methane to aluminum carbide. Let's see how we do it. Now, the first bit is I want to go into methane because methane is something common. Methane is something common between these two equations. It's methane which is connecting aluminum carbide to carbon dioxide, right? So how do I go from carbon dioxide to methane? Well, I know these are the shortcuts that I'll use. I know that the molar coefficients are also the ratio of gases. If you have 1 mole of methane giving you 1 mole of carbon dioxide, it's the same as saying 1 centimeter cube of methane gives you 1 centimeter cube of carbon dioxide, or 1 decimeter cube of methane gives you 1 decimeter cube of carbon dioxide. So if you have 108 cm cube of carbon dioxide, how much methane would have formed this 108 centimeter cube of carbon dioxide? Come on, help me out. How much methane would have formed this 108 centimeter cube of carbon dioxide? The same. 108 cm cube. Because if you're very bad at math, you could say, hey, you have methane, you have carbon dioxide, 1 cm cube of methane is going to give you 1 cm cube of carbon dioxide. 1 cm cube of methane gives me 1 cm cube of carbon dioxide. So if you have 108 cm cube of carbon dioxide, how much methane would have produced this 108? The same, 108 cm cube. So now I have the volume of methane, right? This is the volume of methane. I don't need the volume, I need the moles of methane. I'll tell you why. I want to go from the volume of methane to moles in order to connect these two together, because these two are connected through moles, right? This is not a gas, is it? So I have to convert this into moles. V is equal to N times 24,000, obviously, because it's in cm cube. 24,000 cm cube, done. And then V is 108, moles I need to find into 24,000. Moles, 108 divided by 24,000. What do we get, sir? When nothing is written, it is RTP. I think it should have also mentioned here at RTP, it's mentioned. What do you get? 108 divided by 24,000. 108 divided by 24,000. 4.5 into 10 raised to the power minus 3 moles of methane, right? I'll write it here. 4.5 into 10 raised to the power minus 3 moles of methane. Now, what's common between methane? Now, I've gone from carbon dioxide to methane, and now I have to connect methane to this C right here. I have to connect methane to this C right here. Now the question is, what's common with about methane and aluminum carbide? What's common in these two? Which element is common in these two? This is how the thought process should work. What is common in these two? I'm not like the teachers who are going to make you guys rote learn these type of questions. No. What's common between these two? So the common thing is carbon. So what I can do is, from the moles of methane, I can go into the moles of carbon. And then from the moles of carbon, I can actually find out the mass of carbon, right? So let's do it. Moles of methane is given, and I want to go into the moles of carbon. I know 1 mole of methane has how many moles of carbon? It has 1 mole of carbon. Right here, see? 1 mole of methane has 1 mole of C. So if you have 4.5 into 10 raised to the power minus 3 moles of methane, how many moles of C do you have? The same number. Moles of C. 4.5 into 10 raised to the power minus 3. These are the moles of carbon. These are the moles of carbon. And from the moles of carbon, I want to go into the mass of carbon. Now the question is, sir, why are you going into the mass of carbon? I'll tell you in a moment. So mass equal mole times molar mass. Mass is what? I need to calculate it. Moles is 4.5 into 10 raised to the power minus 3. Molar mass of carbon is 12. What do we get? 4.5 into 10 raised to the power minus 3 multiplied by 12. I get 0.054 grams of carbon. Sir, why did you calculate the grams of carbon? Because understand, the examiner had given me something. The examiner had given me one data. He said that the total mass of aluminum carbide is 0.216 grams. The total mass is 0.216 grams, right? So if the total mass was 0.216 grams and the mass of carbon is 0.054 grams, what's the mass of aluminum? The entire process I did to calculate the mass of carbon, because the total was given to me, and so if I had figured out the mass of carbon somehow, I would have actually figured out the mass of aluminum. So what's the mass of aluminum? 0.216 minus answer. It's a very good question. 0.162 grams. So now I have aluminum's mass and I have carbon's mass. 0.162 grams is the mass of aluminum and 0.054 grams is the mass of carbon. And once you have these two masses, you could calculate the empirical formula for it. How do we calculate to find the formula? How do we calculate the formula for AlXCy? How do I know what X is and what Y is? Once I have their masses, I can actually calculate their empirical formula. Divide by the molar masses, 27 and 12, or divide by the ARs, however you've been taught in O levels. Gives me 6 into 10 raised to the power minus 3, and this is the same. This is 4.5 into 10 raised to the power minus 3. Divide by the smallest ratio, which is 4.5 into 10 raised to the power minus 3, which is 4.5 into 10 raised to the power minus 3. You get what? You get 1.333 ratio 1, right? And so we know that we have to convert it into a whole number. What do? I'll multiply this entire thing with 3, because in order to finish these 0.333s, I need to convert it into a whole number, right? Empirical formula is the simplest whole number ratio. So what do you get? 3 times 1.333 times 3, that gives me 4. So 4 ratio 3. And so you had 4 aluminums and 3 carbons. So Al4C3. This was a lengthy ass question. And so what should be the answer? Is this option given? Absolutely. Al4C3. And so the idea behind it is very important. This is in fact one of the most difficult questions for moles and stoichiometry tested up until this point. So it's good that we covered it, right? So the steps were that I had the total mass, but I wanted to figure out the individual masses of aluminum and carbon. Why did I want to do that? Because I wanted to calculate the empirical formula for it. So how do I calculate the empirical formula to have individual mass of aluminum and carbon? Now, if I can figure out the mass of carbon in aluminum carbide, I can actually figure out the mass of aluminum by subtracting it from the total. So how did I figure out the mass of carbon? He had given me this lengthy ass data. I did reverse working. I went from the volume of carbon dioxide to the volume of methane, and then I went from the volume of methane to the moles of methane, and once I got the moles of methane, I converted it into the moles of carbon, and once I figured out the moles of carbon, I converted it into the mass of carbon, which is what? Which is 0.54 grams. And then once I had the mass of carbon, I subtracted it from the total, and I got individual masses of aluminum and carbon, and then literally calculated the empirical formula. So this was the most beautiful and the trickiest MCQ to have ever been tested for moles and stoichiometry. Loved the idea. If you want, I'll also write the step. If you ever want to calculate the formula, if you ever want to calculate the formula, you need to have the masses of both the elements, right? So how do you get the masses of both these elements here? First, what I did was I got the data. I had the total mass. They gave me the total mass, right? But I don't care about the total mass. Out of using the data given to me, I first of all figured out the mass of carbon. How did I figure out the mass of carbon? I figured it out by, number one, converted the volume of carbon dioxide into the volume of methane, then converted the volume of methane into the moles of methane, then converted the moles of methane into the moles of carbon, then I converted the moles of carbon into the mass of carbon. And then once I did that stuff, I subtracted it from the total. Then what did I do? I subtracted total mass, and then I subtracted the mass of carbon from it to figure out the mass of aluminum. And then I have the mass of carbon and the mass of aluminum. I'll call this A, I'll call this B. So I'll just calculate empirical formula now. These were all the steps that they made you calculate in this particular question. It's crazy. It's beautiful and it's crazy. It's beautiful and crazy at the same time. But the examiner was drinking, I think, something when he tested this particular MCQ in the exam. Look at the amount of working we did for it. Any other trick that you are taught for this is going to be incorrect. Please understand. There are no tricks to it. It's just quick calculations. That's it. Right? And I dissected this MCQ to its utmost detail because I'm going to also add this in the lessons now because I loved this MCQ. Here, a sample of propanoic acid, which is, for now, you might have not studied organic chemistry. So this is what propanoic acid looks like. And he's saying reacts with excess magnesium. So in one case, he's reacting it with excess magnesium. And in the other case, he's reacting it with excess sodium. You might have forgotten organic chemistry, but this is an acid-base reaction. An acid and metal reaction. Metal will displace the hydrogen in the acid. You're going to get, this is the negative ion, CH3, CH2, COO minus. This is the negative ion, right? And magnesium makes a positive ion of 2 plus. So the formula is going to be CH3, CH2, COO, magnesium 2 will multiply here. For one magnesium ion, you need 2 propanoate ions, and you're going to get hydrogen. I'm going to multiply this with 2 because you had 2 of this, so 2 of this. And how much hydrogen do you have? 2 H's on the left, 2 H's on the left, and 2 H's on the right here. These H's. I'm just talking about these H's that are going to be converted into hydrogen. So 2 on the left and 2 on the right. Good stuff. For sodium makes a 1 plus ion. And this is CH3, CH2, COO minus ion. So what do you get? CH3, CH2, COO, Na plus hydrogen. Done. And you had 1 hydrogen on the left and you have 2 on the right. So what should I do with this 2 to make it 1? What should I multiply it to make it 1? 1 over 2. Right here. 1 over 2. Done. Now the question is, let's now read the question. All that for 1 mark? Yes, Fatima, all that for 1 mark. My job is to do every mark with you. I'm a teacher. I can't afford to skip an MCQ. You can afford to skip an MCQ in A-levels. I can't. So I have to do every MCQ. And it's important, yeah. It's important. It's very important. Maybe in this particular paper, all the other, some of the MCQs were 1 second MCQ. So the examiner compensates for these things. So, let me eat this pomegranate. You try to solve this. I think, sorry for chewing this loud into the microphone. Now, he's saying a 3.7 grams of propanoic acid is reacted here and the same 3.7 grams is reacted here. What is the volume of gas formed at standard temperature and pressure? STP. So we're going to use, it's in centimeter cube, so we're going to use 22400 cm cube because one decimeter cube is 1000 centimeter cube, so 22.4 dm cube, which is at STP, is 22400 cm cube. Done. Now, he's saying which volume of gas is produced. Convert the data given to you into moles. So mass equal mole times molar mass. 3.70 grams is given. Mole, I don't know, of propanoic acid. Molar mass of propanoic acid is what? You guys can calculate it. How many carbons do you have? 3 carbons, 12 times 3. How many hydrogens do you have? 3 plus 2 plus 1. That's 6. Plus, how many oxygens do you have? 2. So that's 74. right? So 3.70 divided by 74 equals N. What is N equal to? 3.70 divided by 74. You have 0.05 moles of propanoic acid. Done. Now, in the first case, you'll realize that 2 moles of propanoic acid gives you 1 mole of hydrogen. In that, 2 moles of propanoic acid gives me 1 mole of hydrogen. This is for case A, right? So 2 moles gives me 1 mole. If you have 0.05 moles, how many moles of hydrogen would you get? N is equal to 0.025 or 0.0025? 0.025, sorry. So you're going to get 0.025 moles of hydrogen. Done. Calculate the volume for it. V is equal to moles. And please, you have to do it with the calculator. I am doing it right here in front of you. Why 22,400 cm cube? Because it is at STP. So that gives me 560 cm cube. For the first bit, 560 cm cube of hydrogen gas should form. So for magnesium, C and D are wrong. 550 is the correct option for now. For B's case, you know that you had these many moles of propanoic acid, didn't you? And you know that 1 mole of propanoic acid gives me half a mole of hydrogen. So 1 mole of propanoic acid gives me half a mole of hydrogen, or 0.5 moles of hydrogen. 0.05 moles of propanoic acid would give me how many moles of hydrogen? And cross multiply, what do you get? 0.05 into 0.5. 0.025, the same. And 0.025 moles converted into volume, V is equal to N times 22.4 or 22.400 effectively, because 22.4 dm cube is 22,400 cm cube, right? So what do you get? 0.025 times it by 22,400. Please, I'm doing all these steps for you. You don't have to do all these steps in the exam. It's simple. After you see that the moles are the same, what volume did you get with 0.025? It was 560. So with 0.025, you're going to get 560. Please don't waste time here. I have to do it to make sure that even the students who are, the weakest can understand it. That's why I'm doing all these steps. So 560 cm cube in both cases. A is the correct option. थक गया हूँ यार मैं तो. I'm tired. Sample X is added to water and made up a volume of 200 cm cube. This gives a solution of this much. Okay. So you understand that you have a certain concentration and you have a certain volume. And he's saying, what is X? You know that the moles before dilution and after dilution are equal. So if I calculate the moles, then I'll just look at all the option to calculate the moles, and whichever moles coincide with these moles, that's going to be the correct option. So N equals CV. Moles I need to calculate. Concentration is 0.1 times it by volume. What's the volume? 200. 200 divided by 1000. I want to convert it into cm cube, right? Because dm cube, because this is in dm cube, this should also be in dm cube. So what do you get? 0.1 times 200 divided by 1000. 0.02 moles. So these are the moles of what? These are the moles of HCl after dilution. So the moles of HCl after dilution should be equal to the moles of HCl before dilution. Just calculate the moles. N equals CV, and you just need to do it in the calculator. That's it. Just calculate. See, C is 1, V is 10, and it's in cm cube, so divided by 1000. So what you need to do is, instead of writing the formula over and over again and writing this on the piece of paper, you know that this is my concentration and that's my volume. I just need to plug concentration and volume into the calculator. 0.9 is the concentration, volume is 30, but divided by 1000. You just need to plug it in the calculator. Sir, 0.4 is the concentration into 50 divided by 1000. Plug it into the calculator. 0.3 is the concentration into 100, and in cm cube, plug it into the calculator. Just have to plug it into the calculator. Sir, it's C. Let's calculate it. 0.4 times 50 divided by 1000. Absolutely, it's C. C gives me 0.02. You can calculate all the others. None of them would give you 0.02 moles. So C is the correct option. Thank you, Fatima. Sir, what's the purpose of converting it into cm cube? All the options are in D. No. I'm calculating the moles here, Hamza. I'm calculating the moles. How in the world are you supposed to calculate the moles? You're given the volume and you're given the concentration. How can you calculate the moles from concentration and volume? The only way you could do that is to convert this into dm cube, because if you don't convert it into dm cube, I'll tell you what's happening. 0.1 is mole per dm cube, right? And 200 is cm cube. So how in the world do you get moles? No, you don't get moles. After you multiply them, you get 0.1 moles cm cube per dm cube. That's what you get. But that's not required. I need moles. So I convert this cm cube into dm cube, right? By dividing it by 1000, because cm cube cuts out, and what is left at the end? Sorry, what I'm saying, divided by 1000, this becomes dm cube, right? Then this becomes dm cube. I don't want to go into the mathematical complexity of it, but after you divide it by 1000, I do it like this. After you divide it by 1000, this becomes dm cube, doesn't it? So dm cube and dm cube cuts out, and you get 0.1 times 200 divided by 1000. So that's the moles, Hamza. We're calculating the moles. So I need to convert it into dm cube, because once I convert it into dm cube, only then does dm cube and dm cube cut out, and you get moles at the end of your answer. Please, it's basic math. Huh? I hope you got it. Asan, not rocket science. Done, Hamza? Can I get a yes? Sir, but direct values compare. You could do direct value comparison. That's up to you, kiddo. That's up to you. If you want to do direct value comparison, that's up to you. But I don't want to do value comparisons directly, because that's incorrect concept. Hamza is saying, said there's a shortcut to it. Just say 0.1 times 200, and then 1 times 10, 30 times 0.9, 40 times 0.4 times 50, 0.3 times 100. Just do it directly and compare the values to each other. That's correct, but chemistry wise, it's incorrect. You know, it's not going to give you moles. You can compare the values. You're going to get, yes, Hamza is saying it's going to save time. It's up to you, Hamza. If you know the concept, then it's fine. You could do that. As long as you know that whatever you're calculating is not moles. Okay, oxygen can be prepared by a reaction of potassium manganate, hydrogen peroxide, and sulfuric acid. Each H2O2 molecule loses 2 electrons in this reaction. The products of this, how many moles of oxygen gas are? Oh damn! A-levels is trying to mix chapters together as well. A-level is trying to mix chapters. Let's talk about this MCQ. I also want to dissect this now. I am loving this, yaar. For the first time, I'm loving this. Because back in the day, I used to feel that it's pretty boring. Nothing new, nothing challenging your critical thinking. Okay, let's talk about this. And I want to dissect this MCQ. Please, I know some of you guys may be able to do it in a split of a second, but I don't want to do it in the split of a second. I want to dissect it for you. Okay, now, he's saying that how many moles of oxygen gas are produced when KMNO4 reacts with H2O2 in acidic conditions, right? So I'm going to use this side. KMNO4 reacting with H2O2. Now, you understand that in order to figure out how many moles of oxygen gas are produced, what can I do? I know that I'm just going to, in KMNO4, MNO4 minus is actually the negative ion, right? K is the spectator ion always, right? So I need to first figure out the half equations. And then I'm going to combine the half equations to find the full equation, and therefore figure out the moles of oxygen, right? The question is, how do you figure out the half equations? This is potassium manganate. I'm then not writing potassium because it's the spectator ion. You all know that from redox, right? I don't care. If you want to write it. I don't care. So I don't know what manganate is going to go into. Although you should know it, but even if you don't, it's not required by the examiner to know it. So he's given you some ideas. What has he given you? Think about it. He's saying oxygen can be prepared by the reaction of potassium manganate, hydrogen peroxide, and sulfuric acid. Okay. Each H2O2 molecule loses 2 electrons. Wait a moment. Each H2O2 is losing 2 electrons, right? Now, how do you balance out these half equations? How do you balance out these complex half equations? If 2 electrons are lost, how are you balancing these electrons with? I'm doing reverse working. These electrons were balancing what? They were balancing the hydrogen ions, weren't they? These electrons were balancing the hydrogen ions. And why? How many hydrogen ions were you adding? 2 hydrogen ions? What does that mean? That means how much oxygen would you have? How much oxygen you have? You have O2 right here. Because see, if it loses 2 electrons and you balance it with 2 hydrogens right here, here you have 2 H's and 1 O2, right? 2 H's and 2 O's. So it's basically doing reverse working. See, he just gave you this information that hydrogen peroxide loses 2 electrons. Okay, if it loses 2 electrons, how do I balance out electrons with the hydrogen ions? Okay, I have 2 hydrogen ions and 2 electrons. And so 2 H's and 2 H's on the left. What's left? O2. What's left? O2. Good. That's the first half equation that I got. It's just working with whatever the examiner is, guiding me with. Okay. Now, the next bit that the examiner is saying is, in this reaction. The other products of this reaction are potassium sulfate. Now, potassium sulfate, manganese 2 sulfate, and water. Now, this is very important to understand this. Manganese 2 sulfate. What does that mean? Manganese 2 sulfate formula is MnSO4. Why is it MnSO4? Because manganese 2 mean Mn has a charge of 2 plus, SO4 is 2 minus. So he is saying that in MnO4 minus is effectively going into Mn2 plus. That's what he's saying. I don't care about the sulfates, because potassium ion, sulfate ion, they're all spectator ions. I don't care, because the change in oxidation numbers are here. The MnO4 minus, the Mn in MnO4 minus is plus 7, and this is plus 2, right? So you're going from plus 7 to plus 2. That's effectively what you're doing. Now, how do I balance these equations? First, make sure that all the atoms except for oxygen and hydrogen are balanced. Mn, balanced. Next step, balance out the oxygens with waters. So plus 4H2O. Next step, balance out the hydrogens in water with the hydrogens on the more deficient side, the hydrogen ions on the more deficient side. So you had 4 times 2, 8 hydrogens on the right. I have 8 hydrogens right here, 8 H pluses. Done. Next step is to balance out the charges on both sides. How do you balance out the charges? So you have 8 H pluses, 8 positives here, minus 1. So the overall charge on this hand side, is plus 7, the overall charge. And on this hand side, the overall charge is plus 2. And what do? We balance out the more positive side with electrons. So how do I make this plus 7 equal to plus 2? By adding 5 electrons. Now on both sides you have plus 2 charges, right? Now I can balance out this equation. I can add these two half equations. But before I add these two half equations, I know that the electrons gained must be equal to the electrons lost. So I need to make them equal. How do I make them equal? Sir, how do I make 2 equal to 5 or 5 equal to 2? It's LCM, literally. What should I multiply this 5 with? Multiply it with 2. And what should I multiply this 2 with? Multiply it with 5, right? Because I have to make sure that the electrons are equal. 2 and 5's LCM is 10, right? I hope you guys know basic math. 1's are, this is 5, 5 1's are, and that's 1, right? So 10 is the LCM. So what should I multiply 5 with to get 10? 2. What should I multiply 2 with to get 10? 5, right? Or what you could do is use a shortcuts. Whatever electrons are written here, multiply it here. Whatever electrons are written here, multiply it there, right? So now let's add them. Now I'm not concerned about anything. I don't even want to add this equation. I'm only concerned about this oxygen right here. And I'm only concerned about this MnO4 minus. Because that's what he is saying. He is saying how many moles of potassium manganate should react with excess H2O2 in acidic conditions. How many moles of oxygen gas are produced when potassium manganate. So I'm only concerned about potassium manganate. I'm concerned about this fella and I'm concerned about this fella. I'm not even going to add these two equations. I know that you have 2 MnO4 minus ions. How do I know it's 2? 2 is multiplying with MnO4. It's multiplying with everything, but I'm just talking about MnO4 minus. So 2 MnO4 minuses are giving me how many oxygens? So 5 times O2. 5 O2s? Done. 5 times O2, 5 O2s. But he is not asking you about 2 moles of MnO4 minus potassium manganate. No, he's not asking about 2 moles of potassium manganate. He's asking about 1 mole of potassium manganate. So if 2 moles give me 5 moles, 1 mole should give me how many moles? 1 mole should give me how many moles? 2.5 moles of oxygen. And do we have 2.5 moles? We should have that. B is the correct option. I'll also add this to the lecture slide. So somebody remind me to add question 7 and what else? What other question did we do? Question 4. Question 7 and 4 I want to add to your stoichiometry list. This is a good question. Very beautiful question. Very beautiful question. Okay. Oh. Give me a moment, yeah? Let me just take a deep breath. Next question. It says, what is the total volume of gas produced when 0.01 mole of anhydrous magnesium nitrate is completely decomposed? We know the reaction. Magnesium nitrate, when it completely decomposed, we've studied it in chapter 4. What happens? It forms MgO, metal oxide, plus nitrogen oxide, plus oxygen gas, right? And if you were to balance this, is 2 here and half here, always. And you could balance it. See, if you want to balance it like a newbie, you could still do that. 1 mg, 1 mg. 2 times n. 2 n's on the left. You only had 1 n on the right, so I added 2 here. 6 O's on the left, 1 O already here, 3 O's already here, and I needed, what happened? What did I do wrong? 6 O's on the left, magnesium oxide plus N, oh this is NO2, yeah, why am I writing NO2, right, plus NO2. So, how many oxygens do you have already? 1, 2 times 2, that's 4. So 5 oxygens you have already, you need 6. So what should I multiply 2 with to get 1 more? 2 को किससे मल्टीप्लाई करूँ टू गेट 1 more, x इक्वल टू 1/2 ना. Yeah, Mani is saying I'm speechless. Whee! Okay, it's fine. Allah khair karenge. Okay, so you're given the moles. Now, he's saying how much total volume is produced. Total volume of gas is produced. This is also a gas, and this is also a gas. Now, you can do it directly with the calculator. See, you have 0.01 moles of MgNO3 whole twice, right? So, how many moles of oxygen are you going to get? Half of this. So, half of 0.01 moles are the moles of oxygen. And how many moles of NO2 would you get? Times it by 2. Because see, now it's time to do direct stuff. 1 mole gives you 2 moles. So 0.01 would give you what? Times it by 2, literally. Now it's time to, gear up these things in MCQs to save time. So what are the moles of oxygen? 0.01 times 2. Sorry, 0.01 divided by 2. 5 into 10 raised to the power minus 3. These are the moles of oxygen gas that you get. 2 into 0.01. That you get 0.02. And then just multiply both of them with 24,000. Is it at RTP? At room conditions, yes, RTP. So measure it, multiplied by mole times 24,000 is going to give you the volume, right? So what do you get here? This into 24,000, it gives me 480. And 5 into 10 raised to the power minus 3 multiplied by 24,000 gives me 120. So what's the total volume of gas produced? 480 plus 120, 600. And so that's C. Which pair of the formula is correct? I hope everybody can do this. Silver has a 1 plus charge and CO3 is 2 minus. Cross multiply, that's correct. This one is wrong because ammonium ion has a charge of 1 plus and nitrate is 1 minus. So the formula is NH4NO3, not NH4 thrice. So it's pretty simple. It's a very easy basic question. It's the first question of the exam, that's why. And then K2HCO3 is incorrect because potassium has charge of 1 plus, HCO3 has a charge of minus, right? It's hydrogen carbonate. So it's HCO3 minus is, it has a charge, it's the negative, and it's not CO3. CO3 2 minus has a 2 minus charge. This is HCO3 is minus 1. So that's incorrect. Next. AgHCO3. Ag is charge 1 plus, HCO3 is minus 1. So cross multiply, you get this formula. Absolutely. K3PO4 is correct. Absolutely. K is 1 plus, PO4 is 3 minus. Cross multiply, you absolutely get C. Why is D incorrect? D is incorrect because ammonium ion has 1 plus charge. PO4 is 3 minus. Cross multiply, get NH4 whole thrice PO4, not whole twice. So I think this was the most basic question. How many molecules are present in 62 grams of solid white phosphorus? White phosphorus P4, right? Israel uses it again, Gaza, which is banned internationally effectively. But okay, I want to find out how many molecules. So first convert the mass into moles, moles into molecules. So mass equal mole times molar mass. Mass is what? 62 grams. Moles I need to figure out. Molar mass is what? 31 into 4. It's 31, right? Phosphorus is 31. 31 into 4. I get 124. So 124 equals the moles. N is equal to 62 divided by 124. 0.5 moles. And so 0.5 moles of P4. How many molecules are there? So the number of molecules equals the number of moles times it by the Avogadro's constant. And you could represent Avogadro's constant with L. Remember, I've told you this multiple times. So it's basically 0.5 into L is just what? 1 over 2 times L. Or you could write it as its basic math, L over 2. 0.5 times L is what? 1 over 2 times L. Half into L. 0.5 is half into L, or L over 2. And so that gives me C. I think these were the most basic question asked after a long ass time. Which of these samples of gas contains the same? Oh, okay, this is a beautiful question. A beautiful play of words. A beautiful play of words. Now, that's why I say always be very vigilant whether molecules is written or whether molecules is written or whether atoms is written, right? Why? Because he's saying which of these samples of gas contains the same number of atoms as 1 gram of hydrogen gas. The same number of atoms as 1 gram of hydrogen gas. This is a question that almost 50% students would get wrong. Maybe not 50, maybe 80, 90%. Why? Because they don't read properly. See, he's given you 1 grams of hydrogen gas. Mass equal mole times molar mass. Mass is what? 1 grams. Moles, I need to calculate molar mass of H2. What is 1 times 2? 1 divided by 2 gives me moles. These are the moles of 0.5 moles. These are the moles of what? These are the moles of, please tell me, what are these the moles of H2? Are these the moles of hydrogen gas? Yes, because I used the molar mass of hydrogen. Sir, do I need the moles of hydrogen gas? Do I need the moles of molecules? This is a molecule. I don't need moles. I need moles of molecules. I don't need molecules. If I multiplied this with the Avogadro's constant, I would get the number of hydrogen molecules. I don't need molecules. I need atoms. So first convert these moles of molecules into the moles of atoms. 0.5 times 2. And so I effectively need 1 mole of hydrogen atoms. Right? So I have 1 mole of hydrogen atoms. And effectively 6.022 into 10 to the power 23 atoms of hydrogen. But I just want to now check out which of these have the same moles of atoms. The same moles of atoms. Carbon dioxide is given to you. Again, mass equal mole times. I'm going to do one with the equation, and then the others I'll do it directly in the calculator. That's the step for it. That's the basic trick for it, right? The quick way for it. So you're given 22 grams of carbon dioxide. Moles are not given. Molar mass is 44 for carbon dioxide. What do you get? 22 over 44. 22 over 44. And now you see the trend here. What's the trend? N is equal to what? 0.5 moles. And these are the moles of carbon dioxide. Do I need the moles of molecules? Do I need the moles of molecules, or do I need the moles of atoms? I need to check out the number of atoms. So I need the moles of atoms. So 0.4 times 3. You have 3 atoms right here, right? So 0.4 times 3. How many moles of atoms do you have? And so now you see the trend here, 0.4 times 3. Now, if you are smart enough, you would save your time now. Because now what you see is you say, hey, you're given 22 and 44, 22 and 44. What I can do is, again, 22 divided by 44, so 8 divided by 16, 20 divided by 20, 8 divided by 48, and then multiplied with the number of atoms. Multiplied with 5, multiply this by 1, multiply this by 3. So now this is the quick way of doing it. 8 divided by 16, multiplied it by 5, because that's effectively you have 5 atoms in one CH4, right? Now again, 20 divided by 20 into 1, and then 8 divided by 48 into 3. What do you get here? 8 divided by 16 into 5. 8 divided by 16 into 5, that's 2.5 moles, and this is 1 mole, which is the correct option. And 8, these are the moles of atoms, effectively moles of atoms, right? So 8 divided by 48 into 3, this is 0.5. The examiner said a lot of students selected 0.5, which is incorrect. Because also understand these, we're talking about the moles of atoms, the number of atoms, not the number of molecules. So this is the correct option, because you have 1 mole of atoms here, you could multiply it with the Avogadro's constant. You're going to get the same number as 1 mole of hydrogen atoms. So C is the correct option. Awesome. कितने रहते हैं यार? I'm tired. 2, 3, 4. Okay, 3 more MCQs to go. What is produced when 60 grams of nitrogen monoxide reacts with excess carbon monoxide in a catalytic converter? So you have nitrogen monoxide, carbon monoxide gives me what? N2 plus carbon dioxide, doesn't it? And you have 60 grams of nitrogen monoxide, okay? So 60 grams, and how do you balance it? Just half this stuff. That's it, literally. So I have 60 grams of nitrogen monoxide. I can convert it into moles. Mass equal mole times molar mass. Mass is 60. Moles I need to calculate. Molar mass of nitrogen monoxide is what? 14 plus 16. What do you get? 30. N is equal to 2 moles. Now, please, I want you guys to use shortcuts now. It's very pertinent that your calculations are now so strong that you could use shortcuts, which is what? 1 mole of nitrogen monoxide gives me half a mole of N2. So how many moles of N2 do I have? 1 mole. Don't I? Because these are MCQs, so 2 divided by 2, that's 1 mole. And 1 mole of NO gives me 1 mole of carbon dioxide. So how many moles of carbon dioxide do I have? How many mole? If 1 mole gives me 1 mole, 2 moles should give me 2 moles. Shouldn't it? So instead of doing cross multiply over and over again, it's time we grew up. because these are very pertinent to save time in the exam. It's very important. And now I need what? I need the masses. Mass equal mole times molar mass. What's the molar mass of nitrogen? 14 times 2. Mass equal, see, mass equal mole times molar masses. So times it by the molar mass of carbon dioxide, which is 44. What do we get? 88 grams here. And what do we get? 28 grams here. Search for 28 grams and 88 grams. Where do you have 28 grams? 88 grams of carbon dioxide, so B and A are wrong. And 28 grams of nitrogen. C is the correct option. Sir, are these the most difficult MCQs from the examiner report? No, these are easy ones. The ones that I did at the start, question 4 and 7, they were pretty difficult. They needed a lot more thought process, you know. I won't say they were difficult. I'd just say, I'd just say they needed a lot more thought process. I won't say they were difficult. These are just basic O-level questions. The only challenging questions that I saw up until now are is question 7, probably. Because I don't think students would have deciphered how to make these half equations. So question 7 and maybe like question 4. Question 4 and 7 were a little challenging for students. I'm joking. I'm also doing them for the first time. So if you don't know anything, just choose option C. What do you mean if I don't know anything? Acha, C. Okay, I get it. So from question 8, there's C. Somebody also check it with a marking scheme later on. But I think it's correct. His concepts are strong, it's correct. C. Yeah, that's good stuff. I am enjoying this stuff. I'm enjoying this. Which compound contains 74.2% by mass of sodium? So if you remember O levels and IGCSE, if you don't watch the videos, this is sodium carbonate, this is sodium chloride, this is sodium hydroxide, and this is sodium oxide. And fun fact, I already know, I think D is the correct option. And I'll tell you how I did it just by looking at it. See, this is how you save time. So I finally got my theory booklet. That's awesome, Fatima. I'm so proud of you. Awesome work. You know one thing? Did you actually pay all the delivery charges for it? That's crazy. If you paid the delivery charges for it, that's wild. You know, did you get it? Like shipped? You're from Saudi, right, Fatma? KSA or Kuwait? I made a person get it for me. Okay, Dubai. Okay, awesome. That's good. Now see, how did Sir Suleiman know it's D? Sir, he took 1 month. It's okay. Now you can slowly and gradually start working. How did Sir Suleiman know it's D right off the bat? These are the techniques, the quick mathematical techniques that you need to know. See, how do you calculate percentage composition by mass of sodium? Part over whole into 100%. That's how you calculate percentages. So sodium is 23, times it by 2, divided by total mass is what? 23 times 2 plus 12 plus 16 times 3. It's pretty quick. Now you have to use your calculators with both thumbs, right? 23 times 2 plus 12 plus 16 times 3. That gives me 106. Sir, for NaCl, it's 23 divided by 58.5. That's the total mass. And into 100, obviously. You're going to do into 100 in the calculator, obviously. So that's that. Sodium hydroxide ke liye, 23 divided by 23 plus 16 plus 1, 23 plus 16 plus 1, that's 40 into 100. And this is ke liye 23 times 2 divided by 23 times 2 plus 16, 23 times 2 plus 16, 62. Can you solve for D only? You guys can solve for all of them, but can somebody just solve for D? What do we get? 23 times 2 divided by 62 into 100. And I was right, 74.19, which is 74.2. Do you know how I knew directly just by looking at it? Think. Sir Suleiman, how would you know? Yes. Awesome. Hamza is absolutely correct. Hamza is saying, sir, you were so smart about it because here sodium's percentage is pretty high, which means the part bit should be pretty close to the whole bit. The part bit should be as close to the whole bit as possible. And when I looked at these, I was like, hey, this would be 23 times 2 is about 46. And, when I just looked at it, I know this is about over 100. So 46 is not as close to 100. That's roughly about 50%. This is 23 and this is 58. So roughly about 50%. This is 23 and this the top notch is, top notch is about 40. So this might be close to it. So I was confused between these two. That's why I just said D is the correct option, because if you look at D, that's like 23 times 2, 46, and then just one oxygen. So it's pretty close. So I went like D, duck. That's it. So I'm not saying to quickly guesswork your way. I'm saying that when you looked at these, automatically your brain should have started to work, and you should have just checked out C and D, and you would have gotten the answer instead of checking out each and every one of them. This is the type of brain cells that you need to use sometimes. Yes, you are right, Fatima. Everybody's right. Last question for the 24-24 set. What is the maximum volume of sulfur dioxide that can be measured at room temperature pressure by burning 100 em cube of diesel fuel, which contains this much sulfur? So I only have this much sulfur. Sulfur plus oxygen gives me sulfur dioxide, right? How much sulfur do I have? 0.8346 grams of sulfur. So convert it into moles. Mass equals mole times molar mass of sulfur is what? 32.1 if I'm not wrong. 32.1 moles equals, what are the moles of sulfur? 0.8346 divided by 32.1, 0.026 moles. These are the moles of sulfur. Again, the moles of sulfur should be equal to the moles of sulfur dioxide. So 1 mole of sulfur gives me 1 mole of sulfur dioxide, and then 1 mole of sulfur gives me 1 mole of sulfur dioxide. So 0.026 moles of sulfur should give me 0.026 moles of sulfur dioxide. And now once I have the moles of sulfur dioxide, I need the volume. V is equal to N times 24,000 or 2400, 24,000, because it's at room conditions. Please be very careful. So how many moles? 0.026 times by 24,000. I don't think STP was tested back in our day. I don't think the concept of STP was there. I think Cambridge also improves with time. It adds good stuff to the syllabus. 624, D is the correct option, right? So that's about it. All the answers are hopefully correct. I know they are correct, not hopefully, I know they are correct, because obviously it's just calculations, right? So that's it, guys. I hope you guys enjoyed the class. Somebody remind me to add question 7 and question 4 to your lectures as well. Question 4 and 7, very important to be added to your lectures. Okay. Love you all. See you guys at 8 p.m. to do states of matter. Love you all. Bye bye. Ciao. Allah Hafiz.